Imagine this. You're staring up at the night sky, admiring the familiar glow of the moon, humanity's constant companion for billions of years. But suddenly, it vanishes. Not into an eclipse, not behind clouds. It's gone, or so it seems. In reality, something far more terrifying has happened. The moon hasn't disappeared. It's collapsed into one of the most mysterious and powerful objects in the universe. A black hole. What would happen to Earth? Would we be sucked in? Would tides stop? Would life on our planet survive? Today, we dive deep into one of the most mind-bending what-if scenarios in astronomy. What if the moon turned into a black hole? Understanding the transformation. To understand the consequences, we first need to grasp what it truly means for an object like the moon to become a black hole. The moon has a mass of about 7.3 x 10 kilograms. That's over 1% of Earth's mass. For any object to become a black hole, its mass must be compressed into an extremely small space, so small that gravity becomes overwhelming and forms what we call an event horizon, the point of no return where even light can't escape. If the moon were to collapse into a black hole, it wouldn't gain any extra mass, but it would shrink down to an incredibly tiny size. Scientists estimate that the moon's Schwarzschild radius is only about 0.1 millimeters, smaller than a grain of sand. So yes, the moon could become a black hole, theoretically. But would anything really change? From Earth's perspective? Gravitational effects. Would we be sucked in? This is where things get interesting. Despite the fear surrounding black holes, their gravitational pull isn't inherently stronger than any other object of the same mass. So if the moon became a black hole with the same mass as before, Earth would still orbit around it exactly the same way, at least from a distance. That means our tides would continue, since they're caused by the moon's mass pulling on Earth's oceans. The orbit of Earth wouldn't be significantly affected. We wouldn't be sucked in unless we got within a few millimeters of the event horizon, which, obviously, isn't going to happen. But here's the catch. While the gravity might stay the same, everything else changes. The visual void? Goodbye. Moonlight, one immediate and eerie consequence would be the disappearance of the moon from our skies. No more silvery glow during moonlit nights. No more full moons or crescent smiles. Just darkness. Because unlike the moon, a black hole doesn't reflect sunlight, it swallows it. We'd only know the black hole was there if material from nearby space began falling into it. As matter spirals toward the event horizon, it heats up to millions of degrees, forming what's known as an accretion disk, glowing brightly in X-rays and gamma rays. Depending on how much material fell into the black hole, we might see intense bursts of radiation lighting up the night sky. Not beautiful moonlight, but violent cosmic fireworks. And that brings us to a very real danger. Radiation risks. A hidden threat if the moon turned black hole started pulling in debris, dust, or even gas from Earth's upper atmosphere. The resulting accretion disk could emit high-energy radiation, including X-rays and gamma rays. While Earth's atmosphere would protect us from most of this radiation, satellites, astronauts, and sensitive electronics in space could suffer damage. Long-term exposure might even pose risks to life on Earth if the radiation levels were intense enough. However, given the moon's relatively small mass and the distance between it and Earth, the risk of significant radiation exposure would likely be minimal, unless large amounts of matter were continuously falling into the black hole. Still, the psychological impact of losing the moon and seeing violent cosmic activity in its place would be profound. Losing stability, a chaotic climate future, perhaps, is the most dangerous long-term effect of the moon turning into a black hole. Gravitational or radiative. It's planetary instability. Right now, the moon acts like a giant stabilizer for Earth. Its gravitational influence keeps our axial tilt relatively stable. currently about 23.5 degrees. This stability gives us predictable seasons and a habitable climate. Without the moon, Earth's axial tilt could begin to wobble chaotically over time, possibly ranging from 0 to 85 degrees. That would mean drastic seasonal shifts. Polar regions receiving direct sunlight for months, equatorial regions plunging into freezing darkness ice ages followed by extreme warming events. In short, Earth's environment would become unpredictable and potentially hostile to complex life as we know it. Final thoughts. The real value of the moon. It's easy to take the moon for granted. Just a glowing rock in the sky, right? But this thought experiment reveals how deeply connected we are to our celestial neighbor. Even if the moon turned into a black hole and didn't immediately destroy Earth, the loss of its stabilizing presence. Its reflected light and its tidal influence would have cascading effects on life, climate, and technology. The moon isn't just a satellite. It's a partner in Earth's journey through the cosmos. And without it, we'd live in a far less stable, far less predictable world. So next time you look up at the moon, take a moment to appreciate it. Because in the grand scale of the universe, having a moon like ours is rare, precious, and maybe even essential for life. If you enjoyed exploring this cosmic what-if, hit that like button, subscribe, and turn on notifications so you never miss another episode of our journey through the universe's most fascinating mysteries. And don't forget to leave a comment. What do you think would happen if Mars turned into a second sun, or if Venus had oceans again? Let's imagine together. Until next time, keep looking up, stay curious, and remember, sometimes the scariest thing in space isn't what's out there. It's what we stand to lose.